At 17,300 feet, the captain of a passenger jet was no longer fully inside his aircraft. The left cockpit windscreen was gone. His upper body had been pulled through the opening and blown back across the roof. A flight attendant held his waist while the airplane climbed through freezing air. This was not a shattered pane. It was a pressure boundary installed with hardware that looked almost right. British Airways Flight 5390 left Birmingham for Malaga with 81 passengers, 4 cabin crew and 2 pilots. Takeoff was at 7:20 in the morning. 30 minutes later, there was a loud bang. Condensation mist filled the cabin, and the cockpit door was blown across the radio and navigation console. The first officer regained control and began a rapid descent. The rushing air was so loud that he could not hear air traffic control acknowledge his distress call. The first crew member into the cockpit grabbed the captain around his waist. The slipstream made it impossible to pull him back inside. Another attendant relieved him as his arms lost strength from frostbite and bruising. He strapped himself into a jump seat and held both of the captain's legs. The aircraft descended to 10,000 feet, slowed to about 150 knots, and turned toward Southampton. At 7:55, 22 minutes after the windscreen left the aircraft, the jet landed. The captain had remained partially outside through the entire descent and landing. He survived with fractures, bruising, frostbite, and shock. Why did the windscreen leave the airplane? It had been replaced 27 hours earlier, and the aircraft had not flown since. Unlike a plug-type window that cabin pressure helps hold in place, this windscreen was mounted from the outside. Internal pressure pushed it outward. 90 bolts were the restraint. The passenger flight became the installation's first full pressure test. Investigators found that 84 of those bolts were approximately 26 thousandths of an inch smaller in diameter than specified. The other 6 had the correct diameter, but were 1/10 of an inch too short. The undersized bolts shared the same thread pitch and could screw into the anchor nuts. They looked, felt, and tightened almost like the correct parts. Old and new bolts had been matched by touch and eye. The parts catalog was not used. Visible gaps around the smaller bolt heads were not recognized as warnings. The deeper failure was the missing backstop. Windscreen replacement was not classified as a vital point, so no duplicate inspection was required. The same shift manager performed the work and certified it. Local quality audits had not detected his working practices. The wrong hardware passed because every safeguard left the final judgment with one person. A critical installation had 90 bolts, but only one unchecked decision. The lasting lesson is simple. If a wrong part can fit, thread, and tighten, the system needs independent verification before cabin pressure becomes the test.